somewhere in the darkness beyond our night sky, far beyond the reach of human travel, there may be a world that looks unsettlingly familiar. Not a fantasy planet, not science fiction, but a real place, discovered not by imagination, but by mathematics, light, and patience. For thousands of years, humans have looked up and asked the same question. Are we alone? And for most of our history, the universe remained silent. Until one day, a space telescope staring at a tiny patch of sky noticed something strange. A star, almost identical to our sun, dimmed. Not once, not randomly, but with clock-like precision. That dimming would lead to the discovery of a planet now known as KEPLER-452b, a world often called Earth's older cousin, a planet orbiting inside the habitable zone of a sun-like star, a world that may have had billions of years longer than Earth, for life to emerge. And today, we're going to take a journey to that world, not by spacecraft, but by story, by science, and by imagination grounded firmly in evidence. For most of human history, planets were invisible. Even the most powerful telescopes could not see them. Stars were simply too bright. Planets were lost in their glare. So astronomers changed the question. Instead of asking, can we see the planet? They asked, can we see what the planet does to its star? This idea became the foundation of the transit method. When a planet passes in front of its star, it blocks a tiny fraction of the star's light. Not enough for human eyes, but enough for precise instruments. In 2009, NASA launched the Kepler Space Telescope, with one mission, to stare at over 150,000 stars. And wait, no scanning, no chasing, just watching. Most stars never dimmed. Some dimmed randomly, but a few dimmed again, and again, and again. Those repeating shadows were planets. And one of those shadows, faint, rare, and perfectly timed, came from a star now called KEPLER-452. KEPLER-452 is not exotic. That is precisely what makes it extraordinary. It is a G-type star, just like our sun, only slightly larger, only slightly brighter, only slightly older. Its light is steady. Its radiation is calm. It burns hydrogen peacefully in its core. Astronomers estimate it is about 6 billion years old, roughly 1.5 billion years older than the sun, which raises a chilling thought. If life developed on Earth in about 4 billion years, what might happen on a planet that had more time? Kepler-452 sits 1,400 light-years away, in the constellation Cygnus, and circling it, once every 385 days, is KEPLER-452b. KEPLER-452b is not Earth 2.0. It is larger, heavier, more massive. Its radius is about 60% larger than Earth's. That suggests two possibilities. It could be a super-Earth, a massive rocky world, or a mini-Neptune wrapped in thick gas. But its orbit changes everything. KEPLER-452b lies squarely inside the habitable zone. Not too hot, not too cold. A region where liquid water could exist on the surface. And it has stayed there for billions of years. Long enough for oceans. Long enough for chemistry. Long enough for evolution. If KEPLER-452b is rocky, its gravity would be stronger. Mountains would be shorter. Atmospheres would be thicker. Storms would be heavier. If you stood on its surface, the sky might appear deeper, the clouds taller, the horizon closer. This is not a gentle Earth. It is a heavier world. Life does not require intelligence. It requires stability, energy, time, chemistry. KEPLER-452b had all three. If life began there, it may have started earlier than on Earth, which means evolution had more time to experiment. Life could be microbial, or complex, or something we have no frame of reference for. Photosynthetic organisms might absorb different wavelengths. Plants, if they exist, could appear darker or redder. Oceans might be deeper, continents fewer. And if intelligence emerged, it would not look like us. It would not think like us, but it would stare at its sky and wonder if it was alone. Here is the cruel truth. We cannot see Kepler-452b directly. We don't know its atmosphere. We don't know its surface. We don't know if it has water. Kepler was designed to find planets, not study them. Even the James Webb Space Telescope struggles with planets this distant. Kepler-452b exists as a shadow, a dip in light, a mathematical certainty. And yet that shadow changed everything, because it proved that Earth-like orbits around sun-like stars are not rare. They are common. Kepler-452b is not important because we can go there. We can't. It's important because it tells us something uncomfortable. Earth is not special. Our star is not unique. Our orbit is not rare. Our conditions may not be extraordinary. The universe does not need us, but it allows us. And that means there could be millions of worlds like Kepler-452b. Some younger, some older, some alive, some silent, waiting. Kepler-452b is 1,400 light-years away. But the greatest distance is not physical. It is the distance between knowing a planet exists and knowing what lives there. One day, we may answer that question. Until then, Kepler-452b remains a reminder that the universe is patient, that life may not be rare, and that somewhere, on a heavier Earth under an older sun, something may be asking the same question we are. Are we alone?